Hi everybody, today's lesson is from section 14-7 and we will be talking about inverses and identity. In algebra, when you take the product of two numbers, if we know we have some number a times 1, we know that that will equal a, and 1 times a equals a. We say that 1 is the identity because anything times 1 is just the number itself. Now, for multiplication, we say the inverse of a is a to the negative 1, or 1 over a. And this is because a number multiplied by its inverse is always 1. So we call that the multiplicative inverse. So if I ask you to find the inverse of, say, 3, for right now we're talking about the multiplicative inverse, so you would say that it is 3 to the negative 1, or 1/3. In geometry, if we have composites of mappings, we say that I is the identity. So if we do a composition of some transformation S along with the identity, we would get back to our transformation S. The inverse of our transformation S is written as S raised to the negative 1 power. And if we do the composition of S and its inverse, we get the identity. In other words, you would get back to where you started from. Okay, so just some quick examples. For number 1, if we want to find the value of 8 to the negative 1, we would just simply say that that's equal to 1 over 8, the reciprocal. For number 2, the value of 3/4 in parentheses raised to the negative 1 power would be equal to 4 over 3. And that's because applying that exponent would give you 3 to the negative 1 over 4 to the negative 1. And then because of the negative exponents, they would switch places, and we get 4/3. For number 3, the value of 7 to the negative 1 raised to the negative 1 would just be 7. That's because 7 to the negative 1 would give you 1/7, but then 1/7 raised to the negative 1 would get you back to 7. So for 4 through 9, we're asked to find the inverse of each of the following. For number 4, the inverse of 3 would be 1/3. And to test it out, multiply 3 by 1/3, and you see that you'll get 1. For number 5, the inverse of 3 over 7 is 7 over 3. For number 6, now we're switching gears. We're going to talk about the inverses of transformations. Imagine if we had a little graph, and we had this point P up here in quadrant 1, and our transformation says that we have to reflect it in the x-axis. That would put P prime down here in the 4th quadrant. So the inverse would be whatever it takes to get us back to that starting point of P. Well, the inverse of r to the x would simply be a reflection in the x-axis again. For number 7, our transformation, it's taking every point xy and mapping it to a new point by doing x minus 2 and y plus 3. So the inverse, which we could write as t to the negative 1, would have to map every point xy to a new point by doing x plus 2 and y minus 3. Again, remember, for inverses with transformations, and specifically with translations, you want to undo what has just been done. So to move it back to the right, we'd have to add 2. To move it down, we'd have to subtract 3. For number 8, we want to find the inverse of a rotation centered around the origin of a degrees. So let's say we took this point P and we rotated it positive a degrees, and that would put P right here at P prime. If we wanted to undo that action, we'd have to come right back to the beginning. Okay, so we would say the inverse of this would be a rotation about the origin of negative a degrees. For number 9, it's a really common mistake to say that the inverse of a dilation centered at the origin with a scale factor of 3 is the dilation centered at the origin with a scale factor of negative 3. That is not the inverse. Remember what a dilation does to your graph. It either expands it or contracts it. A dilation centered at the origin with a scale factor of 3 would take some point P and move it 3 times the distance away So take P prime and put it out here. So since we're trying to undo that, we want to bring that point P prime back to P. So the inverse of this dilation centered at the origin with a scale factor of 3 would be a dilation centered at the origin with a scale factor of 1/3. All right, in our last example, it says the rotation R maps all points 120 degrees about O, the center of hexagon ABCDEF. And this is a regular hexagon, so all of the sides are equal, and all of these angles at the center, O, are going to be equal. They're all going to be 60 degrees, because 360 divided by 6 gives us 60 degrees. So our rotation is defined as mapping all points about the origin of 120 degrees. So it says that we're to give the image of point A under each rotation. So that's going to be the output, but we're going to start at point A, and we have to figure out where we're going to end up. In part A, we have this rotation squared. So we're going to do a rotation followed by another rotation. Do the composition of those two together. And remember, each of those rotations is going through 120 degrees. It's a positive angle measure, so we have to go in the counterclockwise direction. So imagine if we just did one of these rotations, we'd go from A to point E. But we have to follow it up with another rotation of 120 degrees, so that would take us from point E to point C. So the answer for part A is just the letter C. We end up at point C. In our second problem, we're asked to do the inverse. Well, the inverse would move us in the opposite direction. So if we start at point A, and instead of going 120 degrees in the positive direction, which would be counterclockwise, we want to go 120 degrees in the negative direction. So start at A, move through 120 degrees, and notice that we still end up at point C. In the very last problem, part C, it's asking us to do r to the negative 2 in composition with r squared. So remember that we start at the right, and I'm going to use the black pen for this one. So we're starting at point A, and r squared is telling us to go through 120 degrees twice. That puts us at point C, and then r to the negative 2 is saying, okay, now come in the opposite direction. So 120 degrees twice in the opposite direction, and we just get back to point A. So anything that gets you back to where you started from is called an identity mapping. This would be an example of an identity mapping. All right, good luck on the homework.